Hi guys, welcome back to Higher Algebra, Day 1. We're going to go through some norms and then I'm going to take you through a short lesson. It's on transformation, so we've already done this before, but we're going to use it to apply to our new function called exponential functions. And I'm using explain everything instead of notability, so it's going to be new for everybody. Okay, so we're going to talk a little bit about e-learning and our classroom norms, and then we're going to focus on transformations, which it should be all review. Okay, so during this time, I'm going to ask you to be all of these things. So positive, especially patient. We don't know about technology right now, if it's working or not. So just be patient with us as we figure it out. To be present, to log in, do your attendance, Schoology questions, to watch the video. I promise they'll be short, and to complete your homework. Especially to be respectful to your classmates and to me during this time as we try to figure out things. Just make sure that you're being respectful to everyone. Okay, so do you remember? We have 5 functions on this yellow slide that we have used before. We probably did the most with x squared, but we have graphed all of these functions. And we really focused first semester to know how to graph these functions without the tables. However, if you need the tables, this is how you can graph every point on those functions. Okay, so we're going to focus on those and our transformations. So if it was on the inside, was the HIVO. If it was on the inside, it was horizontal, meaning it went left or right. If it was on the outside, that meant it moved the function up and down. Okay, also with reflections, if it was on the inside, it reflected horizontally, meaning that if you had like the square root of x and you reflected it horizontally, that would look like this. And if you had the square root of x again and you reflected it vertically, it would reflect down. Okay, so we're going to do those 6 transformations in this slide. So I'm going to do some highlighting. Let's say that if I highlight something in red, that means that it's going to be horizontal. And if I highlight something in blue, that means it's going to be vertical. Okay. So let's highlight the horizontal. So I think this is on the inside of the function, so it's horizontal. It's going to move at 9. And this is on the inside of the function, that's going to be a horizontal reflection. And this is on the inside of the function, that's going to move 1. And this is on the inside of the function, it's going to move at 2. Okay, so which way does it move it? Well, if it's a minus and it's horizontal, our first transformation is going to be that it's going to go right 1. It's right 9. It's the opposite of what you would think. Minus means right. And this one is a horizontal reflection. And this one, -1, goes right 1. And +2 goes left 2. Okay, so now let's do all the vertical changes. So vertical would be on the outside. That would be the 7 and this 4 and this 2 and the negative, both on the outside, and the +1. Okay, so let's write down what those are. Those are literal. So the -7 means down 7, and the +4 means up 4. On the outside, plus means up 4. The +2 in the next one means up 2, and the negative is a vertical reflection. And then the +1 means up 1. Okay, so our next slide, we're going to do the exact opposite. We're given the transformation and we have to write the new function. Okay, so I like to start with writing the function down and then looking at, we've got a transformation of down 9, that's on the outside, -9. So I just add the transformation to it. Here's my next one, absolute value of x. We're going to go left 2 and down 6. Okay, so let's go left 2, and that's on the inside, and down 6 is on the outside. Parent function, square root of x. To the right 4, That's under the square root, so minus 4, and up 7. And last one, x squared, reflected over the x-axis, that's a vertical. Vertical's on the outside of the function, and down 11, also on the outside of the function. So let's go ahead and try graphing these. So this first function is absolute value of x. Again, you can go back to the parent function tables a couple slides back, or you know that the absolute value is a v. So I just go 1, 1, 2, 2, 3, 3, and I make my v. Okay, and then it looks like I'm going to do my transform function in blue. So it looks like we're going right 3 and up 2. So I'm going to take this guy right here, this point, and go right 3 and up 2. Okay, and then it looks like if I were to graph my v, just a few points, my new function would look like that. So my blue function is my transform function. Okay, let's try another one. Y equals x squared. So we start at 0, 0. 1 squared is 1. 2 squared is 4. And then we reflect that. There's our parabola. Okay, then we're going to do these transformations. We're going to go left 2 and down 3. So once again, I'm going to take this point right here and go left 2 and down 1, 2, 3. I think I end up right there. And then I graph a new parabola where from that vertex I go over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. And there's my new parabola. Okay, we've got a couple more. Square root of x looks like this. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And I think we've got double reflections. I think we've got a horizontal reflection. I think we have a vertical reflection. So it doesn't matter which one you do first. So I'll do the vertical reflection first, which just means your positive 1 becomes negative 1 and positive 2 becomes negative 2. And then I'm going to flip it over the y-axis. So I'm going to send it this way. So I'm going to have a point here still, and then I'll have a negative 1 and a negative 4. And this highlighted function, oops, not my eraser. This highlighted function is my final answer. I don't know if it's going to let me, yeah, it won't let me erase that one. Okay, and then finally, let's take a look at x to the third. It looks like I have a horizontal reflection there. Let's graph the parent. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Negative 1 cubed is negative 1, and negative 2 cubed is negative 8. So x cubed is one of those functions that when you reflect it either horizontally or vertically, it doesn't matter. You get the exact same thing. This technically is a horizontal reflection, but if I graphed it as a vertical reflection, I'd get the same thing. So horizontally, that means that 1 becomes negative 1, 0, 0 stays put. Positive 2 becomes negative 2. And then negative 1 becomes positive 1, and negative 2 becomes positive 2. And I have a horizontal reflection. Okay. And then what if we only had a set of points to work from? So I can see, I'm looking, like focusing what has changed from this point to this point, and I see that the negative 2 has become positive 2. So that could be a couple of things. That could be a reflection, or it could have just moved 4. So then we look at the next set of points, and oh, it looks like we're moving 4. The x values are staying the same, but the y values are changing, and it looks like we're adding 4 each time. Negative 1 goes to positive 3, 7 goes to 11, so it looks like we're changing by 4. So if I don't know my function, I just use f of x. And I want, it looks like it's happening in the y. It looks like we're going up 4. So I'm going to take my f of x and on the outside write plus 4. Okay, let's try it again. Take a look at the first set. -3, -2, -1, +2. So it's changed twice. It has a horizontal change of 2 and a vertical change of well, it could be 4 or it could be a reflection. Let's check the next one. Horizontal change of 2. Oh, it's a reflection because we've gone -2 to 2, -5 to 5, -1 to 1. So it's a vertical reflection and a horizontal change because the horizontal from -3 to -2, that happened in the x. So I'm going to take my f of x. And it looks like if we're adding 2, that means we're going to the right 2. But in my f of x, that's going to look like a -2 because it's going right 2. And I think it is a vertical reflection. To make it do a vertical reflection, that's a negative on the outside. And I think those are 2 of the hardest problems on this worksheet. Okay, so your homework is a PDF that you will find in day 1, and there is a drop box. And then I will correct it and give you a formative score for this day 1 worksheet. Okay, guys, we made it. Day 1. I hope that this video was okay, and we'll just keep feedback. If you have any feedback for me, I'd love to hear it. But this is going to be our format going forward, at least for a little bit. Thanks, guys.